Good evening all. So we were doing properties of regular languages. Okay. Yesterday I have given you one question. Already some of you have answered this question. So what about the remaining? Okay. So minimum of L. So what is the minimum? Any proper prefix of that string should not be in the L. So string which is in the language, but its proper prefix should not be in the same language. Okay, that is. So if I take this question a power n greater than equal to 3, what is the here minimum value of n value is 3. If n is 3, a cube, n is 4, a power 4, a power 5, a power 6. Okay. Now, what is the minimum of L? Minimum of L, guys, minimum of L here, a cube ka, what are the proper prefixes? Epsilon, not in this, a, not in this, a square. The proper prefix of a cube are epsilon, which is not in the language, okay, a, not in the language, a square, not in the language. Therefore, a cube will be in minimum of L, okay. Now, if I take a power 4 का proper prefix epsilon, a square and also a cube. But a cube is here, na? Therefore, we cannot take this one. And a also you cannot take. Only minimum of L is a cube. Okay. Now go for maximum. Okay. So where I have given these properties? No. Yeah. So minimum we have done. We have done minimum. Now we'll go for max. Max of alt, cycle and alt. Okay, whatever. Okay. We'll go for max. Max. What is max? Max of L. Max of L is W set of strings where W is in L. Okay, suppose here what is minimum? Minimum also same, na? So minimum of L is W. W is which is in L. So every string W. So whatever in the language, that string also only we will take in minimum. Here maximum also, but minimum maximum different definitions. So here maximum of L is W such that W is a string in L. W is in L. W is in L, but no, for no string x, for no string x, Wx, for no string x, Wx is in L. Okay, just note down the definition, copy this definition, I will explain. Okay, for no string x, Wx in L, just guys small modification, for no string x, Wx in L, small modification, W is in L but for no string x other than epsilon, I forgot to write, other than epsilon, Wx is in L. Okay, now look at this one. What does it means? What does the meaning of this one? Okay, suppose in general I am explaining. Take a language W1, W2, W3, W4, so on. Okay, now I can take in maximum of L, suppose I am taking W3, when I can take W3 in maximum of L, for W3, this is string W3, for W3 whatever you attach, this is W3 and this is X, if you attach X and W and X concatenation, that string should not be in L. Then what is X here? For any X, Wx should not be. Means W3 followed by anything you attach, that should not be in L. Only it can be W3. So other than epsilon, means example, if I attach W3 epsilon, what is W3 epsilon? W3 only, na? W3 anyway it will be there. Like proper substring, W3 we don't take. So similarly, W3 followed by X, whatever X you take, that should not be in the language. Okay, X can be anything other than epsilon. So with example, with example I will explain, you will understand clearly. Okay, so simply I'll give you the definition again. So we will take the W in maximum of L such that for W, whatever the string you attach, that new string should not be, whatever string you attach, that should not be present in the language. So see the example, you will understand. Let L equal to AB, BAB, ABA, okay, ABAB. Suppose these are the 4 strings in the language. Guys, now look at this one. What is the maximum of L? Okay, now take this one. Take AB. Can I take in AB? Can I take AB in maximum of L? So guys, AB. For AB, whatever you attach, that should not be in L. That is the condition. Okay. Means example, AB followed by A or AB followed by B. Whatever you attach, it should not be AB followed by A or AA or AB, whatever. Okay. Example, I change the question. I am taking this. Okay. ABA, ABA. Okay. ABA, I have attached ABA, ABA, not in the language, okay, not in the language. It doesn't mean that I must take AB in this. No, no. So you have to try for another one. Suppose, listen guys, very simple concept. You take AB, I have attached ABA, it is not there. I will attach AB for B, I attach for AB, I will attach B, ABB is not there, okay, not there, okay, not there. Now you attach for anything you attach. Example, for AB, I will attach AA, AB, AA. So whatever you attach, the result string should not be in the language. Okay, AB, AA, is there or not there? AB, AA, yes, it is there. So it is there. Therefore, whatever this, I cannot take in the maximum. So I repeat clearly, listen guys, I have taken the AB. For AB, whatever I attach the part, that new string, whatever you string getting, that string should not be present in the language. AB, I have attached A, ABA is not there, okay. I have attached B, ABB, not there. I have attached this AB, I attached AA. For AB, I have attached AA. After attaching AA, there is a string. So I cannot take AB in the maximum. Okay, na? Now take this one. BAB. I am taking BAB. For BAB, simple guys. In other words, I say simply, if AB is the suffix or prefix, if AB is the prefix to any other strings in the language, don't take. AB prefix is there, na? Then don't take. Are you following? Now guys, one more thing. So BAB, take BAB. Okay, BAB, for BAB whatever you attach. So having BAB as a substring, as the prefix, do you have the BAB as the prefix? Suppose take BAB. For BAB, whatever I attach, there is no other string starting with BAB. If there is any string starting with BAB, then don't take BAB. Simple. So guys, if you are taking in maximum of L, if you are taking W, simple way, maximum of L, if you are taking W, then there should not be any other string starting with W. That's it. Simple. Okay. So BAB. Do you find any string starting with BAB? No, na? Then I can take BAB in the maximum of L. Okay, I can take, but I cannot take this one because there is a string starting with AB. Okay, now I'll go for ABAA. So ABAA, is there any other string starting with ABAA? Is there any other string starting with ABAA? ABA is there, but ABAA is not there. So whatever you attach for ABAA, whatever the string you attach for ABAA, this one, it won't be in the language. So I can take. Similarly, ABAB is nowhere other. ABAB is no prefix has no prefix in any other string. AB is not a prefix of any other string. So maximum of L is this one. Okay. So I will do a small modification. Example. I am deleting this one. Now look at this one. So AB starting with this, there are two strings, so don't take. BAB, starting with BAB, no other string. Okay, take BAB. Okay. Now ABA. Can I take ABA? So you have to find any string is there starting with ABA. Yes, there is a string starting with ABA. There is a string. Therefore, you cannot take ABA in the maximum of L. Okay, you cannot take ABA and you cannot take AB and take the AB. Is there any other string? Starting with AB? No. AB is not prefix of any other string. Then maximum of L is BAB and ABAB. Okay. Now take the question, guys. Same question. If L equal to same question, whatever we have done today starting, n greater than equal to 3, then maximum of L is very good. Here what is the language? L equal to a cube, n value 3, a power 4, a power 5, a power 6, a power 7, a power 8, so on infinite. Okay. Then what is the maximum of L here? Maximum of L is if I take a cube, for a cube, if I attach a, there is a power 4, so I cannot take a cube. Okay, suppose if I take a power 4 in maximum of L, for a power 4, if I attach 1a power 5 comes. If I attach 2a's, a power 6 will come. So many are there. don't take. If I take a power 6, a power 5, a power 5. For a power 5, if I take a power 5 in the maximum of L, let me check. For a power 5, if I attach a power 6 will come. A power 6 already in this, so don't take a power 5. Okay, don't take a power 5. If I take a power 6 in maximum of L, this is a power 6. For a power 6, if I attach 1a, a power 7 will come. So don't take. For a power 7, if I attach 1a, a power 8 will come. Don't take. For a power 8, if I attach 1a, a power 9 will come. Don't take. For a power 9, if I attach 1a, a power 10 will come. Then don't take, don't take, don't take, don't take, don't take. So, a maximum of L is no, nothing, 5. There is no maximum of L. That's it. Empty set. Good. Yeah. Maximum length string is always in maximum of L. Right. Ankit. Okay, next. So, next, what is the next one? Guys, off. What is off? What is cycle? What is alt? We will see one by one. Off. Next one, off. Off of L is the set of all first offs the set of the set of all first offs of first offs of all the strings in L. Copy this. The set of all first offs of all the strings. Or you can say the set of first offs of all the strings in, you can take this one, the set of first offs of all the strings in L. Okay, now what does means? Very simple, guys, very simple one. Take example L equal to 00 010 1101 0100 1011. Okay. Next 01010. Okay, let this is the okay. Now guys, look at this one here. What is half of L? So half means what, guys? It must be even length. It must be even length. What is the half of odd length? You cannot take odd length of. Okay, na? So that is the reason. Okay, already I got the message. If the string is odd length. Okay, so if the string is odd length, okay, Saurya something. If the string is odd length, we don't take. Okay, so example here, it is even length. Even length first off is what? 0. Okay, next. This is odd length. Leave it. This is even length. What is the first of? 11. Okay, and this is even length. What is the first of? 01. And this is odd length. Leave it. This is also odd length. Leave it. Then this is the only, okay, half of L. Okay, na? Do you understand? Those are having the even length. In those, whatever the first half, you take in half of L. That's it. So if L is regular, half of L is also regular. That's it. Okay. If L is regular, half of L is also regular. Okay, next. Copied? Guys, copied? Next one, cycle. Cycle. Cycle of L. It is set of strings such that we write W as XY if YX is in L. Yx is in L. That means, very simple guys, very simple. Now look at this one. Let L equal to example, let L equal to, very simple one I give, 0 1 0 1 0 1. Only 3 strings I have taken. What is cycle of L? Cycle of L is, okay, so whatever the string you take it, one thing, whatever the string you take it, one thing. So this is only single. Okay, now just leave it aside. I am giving example. In general I am explaining what is the cycle of this one. You divide this into 2 parts. One is this whole string will be, this total string this whole string will be in cycle of L. Okay, other than that, suppose divide into two parts, x, y. Divide into two parts. So x is this one, y is this one. Then we take or okay, otherwise we write w as xy. If okay, I do one thing. Just divide this into two parts as y and x. Then what is the yx reverse? Xy means we write xy in cycle of L. And one more thing, we can divide this as this is y and this is also x, na? Then you take xy in cycle of L. Similarly, you can take y as like this, na? Then you take xy in the language. So for better understanding, with one example, I will explain first. Here, cycle of L is whatever the string you take it. Why sir, why are you taking? Suppose this is y and epsilon is x. What must we write? Xy we must write. What is xy? X is epsilon. What is y? ABC. What is epsilon ABC? ABC. Epsilon ABC is ABC. So that is the reason whatever the string is given, you take that string as it is. Listen guys, every one of you, please look at this. Okay. Now ABC, every string will be in cycle of L. Now look at this. I am dividing this as y and this as x. If yx, then write xy. X is BC and y is A. Okay. So write if you divide into y and x, then take xy. Okay, xy. Now suppose guys, I divide this as y and this as x. Okay, I divide this as y and this as x. Then xy. What is xy? X is what? C. Y is what? AB. So CAB will be there. And what else you can take? You can take this as y and this as x. X is what? Epsilon. Xy means epsilon ABC. Already we have taken. So this is the cycle of L. Do you understand? Guys? So ABC. Again I repeat this one. If anybody has any doubt, please look at this guys. Some in online class or offline classes, some students will get doubt in this one. ABC. So this is the language. For this I am writing the cycle of L. So you take the string as it is. Okay. Now divide this into any two parts. I am dividing this as y and this as x. So any two parts. So yx. Then take xy. What is x here? X is what? BC. And y is what? A. BCA. So BCA will be here. And otherwise do one thing. So you divide this as y and this as x. Xy. What is xy? X is C, y is AB. So take CAB. Otherwise you take all this as y. Then epsilon, then xy is what? Epsilon ABC already there. This is the answer of cycle of L. Okay. Now guys, hello. You come to this one. Okay. Now as it is, 0 will be there and 0 is the single. You cannot divide into two parts. Leave it. And 1 0, take 1 0. Every string you have to take as it is. Now guys, 1 0. I will divide this as y, this as x, yx, two parts. Then xy. What is xy? If yx is in L, we write xy. Okay, xy. What is x here? 0. What is y? 1. So take 0, 1. Okay, na? Done. This is done. Next part. This one. Take as it is. 1 0 1 you take as it is. Now divide this into two parts. This is y. And any two parts, this is x. If yx is, then xy. What is x here? 0 1. And what is y? 1. So 0 double 1 will be there. Okay, otherwise do one thing, guys. Okay, do one thing, take this as y and this as x. Then what is xy? What is xy? X is what? 1. What is y? 1 0. So 1 1 0 will be there. 1 1 0. Okay, next guys, if I take this whole as y, then x is what? Epsilon 101 is 101 already there. So this is the cycle of L. Okay, so 0 1 0 0 1 1 0 1 0 double 1 1 1 0. Very good. Okay guys, others, do you understand or shall I repeat? Cycle of L, guys, not maximums. It is cycle of L. Okay, enough? You want one more example? Is this enough, or you want one more example? So guys, properties, total properties. See how many properties I have given. So starting with, okay, union, intersection, concatenation, clinch closure, positive closure, quotient, left quotient, right quotient, then exclusive OR, exclusive NOR, NAND, NOR, homomorphism, inverse homomorphism, then substitution, then H of H inverse of L, H inverse of H of L, then prefix, suffix, minimum, maximum, then off, cycle, alter. One more thing, alternative is there. So many properties with examples I am giving. Okay, so you may not find these examples for, of course, union, intersection, homomorphism and quotient, you will get many places, but this cycle and minimum, maximum, so these are simple concepts. Okay, but if you don't know, unnecessarily if any question comes, unnecessarily you will lose the marks. But see, cycle, you just divide the string into any two parts. So all possibilities you have to go. So if you divide into two parts, then reverse this x, y. Then it will be in a cycle of L. What Ankit Gol, what not required? What not required? I did not get it. Okay. Oh, example, one more example not required. So this example also have you taken? This L equal to ABC. Okay. Next, alter. Alt of W1, W2. Alt of W1, W2. Next, last property. After this, where the regular languages are not closed. After that, what are the converse of properties? What is converse of properties? With that, the properties will be completed. Okay. Next one, alt of W1, W2. What is alt of W1, W2? Very simple, guys. Let W1 equal to A1, A2, A3, so on, AN, and W2 equal to B1, B2, B3, so on, Bn are the two strings of same length, then alter of W1 comma W2 is taking alternative symbols of W1, okay, W2. Guys, simple. Directly I'll tell you, I'll give the definition letter. Whenever you are writing the order of two strings, they must have same length. See, n symbols. Here also n symbols. So whenever you are writing alter of two strings, they must have the same length. If lengths are not same, so you cannot write alternative. So this W1, W2 are two strings of same length. Then alter of W1 comma W2 is taking alternative symbols of W1 and W2, starting with first symbol of W1. So then alter of W1 is W1 comma W2 is taking alternative symbols of W1 and W2, okay, starting with first symbol of W1, Why? Because alter of W1, first is W1, starting with first symbol of W1. First symbol of W1. Okay. So guys, let W1 equal to W2, W1 and W2 equal to two strings of same length, or the two strings of same length. Then alter of W1 comma W2 is taking alternative symbols of W1 and W2 starting with first symbol of W1. That is, guys, look at this one, you will understand. That is alter of W1 comma W2. Alternative, alt of means the alternative, alt of W1 comma W2 alternative. So start with A1, then B1, then A2, then B2, A3, then B3. Alternative symbol of W1 and W, alternative symbol of W1 and W2, starting with W1, AN, then BN. This is alt of W1 comma W2. Okay. Now guys, if you want to find the alternative of two languages, this is of two strings, na? So then alt of L1 comma L2, is equal to nothing but those are of same length, strings of same length in L1 and L2. So take a string L1 take a string in L1, suppose W1, and take a string L2, suppose W2. So W1 and W2 length must be same. So alt of L1 comma L2 equal to alt of W1 comma W2, where W1 belongs to L1 and W2 belongs to L2. Okay, suppose guys, there are the strings like this, 0, 1, 1, 0, 1, two strings. Here 1, 0, 1, 1 and 0, 1, 0, 1. Okay, like guys, look at this one. Here length of this one is 2. So you can write alternative with 0, 1 with this one and also this one. But you cannot write alternative with this one. So if I write alt of L1, L2 is take 0, take Okay, take this one and this one. 0 followed by 1, then 1 followed by 0, alternative symbols. Okay, this is done. Now take with this one, because these two are same symbol, na? Same length, na? This is this and this same length. So 0 followed by 1, then 1 followed by 1. Okay, next. So this length is 2, this length is 3. You cannot write, leave it. This is done. This is done. Now take this one, length is 3. Do we have any string of length 3? No. Then you cannot write any other string. So just close this one. Only this. Samajh gaya na? Those are having same length in L1 and L2. So take multiple combinations there. Example, this is length 2. And example, here one more string is there, 0, 0 example. Then write the 0, 0 with this one and also this one. Okay. Now, so this is alt of L1, L2. Okay. 0, 1, 1, 0, 0, 1. Okay. So guys, take this definition. Alt of So, does anyone has any doubt regarding these properties till now? Whatever we have I have explained. So, any properties, any doubts? Have you read the notes? And first of all, yesterday I told you to do the workbook. So, regarding homomorphism and all, have you has anyone solved? The questions you can see from 86. The questions you can see from 86. Okay. 100 plus questions done. Ankit Gol. Very good. And tell me, are you getting the questions? Do you feel any difficulty in any question? Madhav Mishra equivalence class we will do in Myhill-Nerode theorem. Myhill-Nerode theorem we will do. Okay, you will understand. Okay. Mohammed, yes sir, solved many questions from the workbook. last example once again. Abhijit Manoj Verma. Look at this. Abhijit, take this string. What is the length of the string? 2. And so you can write the alternative with this. As this is length 2, so take the strings of length 2. This is length 2, this is also length 2. So we can write alternative. This is 0 1. Okay, 0 1. I am taking 0 1 and 1 0. Okay, so start with 0. Okay, and see, actually I have given the wrong, that is the reason you are getting confusion. Okay, I do one thing. Let this is L1, this is L1 and this is L2. Maybe that is the reason. Okay, this is L2. Okay, L2. Now look at this, mister. So take a string length 1, sorry, this length 2, length first string, and here also whatever the strings of length 2 you take them. Here length 2, here also length 2. Take this 0 followed by this first, in this string first symbol 0, in this string first symbol 1, in this string second symbol, in this string second symbol. Done. Okay na? Next. So here one more string is there of length 2. Take first symbol of this string 0 and first symbol 1. Second symbol of this 1 and second symbol. Okay, done. So this is length 2, this is length 4. Not possible. Take this one, length 3. Do we have any string of length 3? This is length 2, this is length 2, this is length 4. No. So you cannot find. This is the answer. Subhi Goyal, do one thing. More question not required. Whatever we have done, that is enough. So do the workbook. You will understand. Okay. There are so many questions in the workbook. In chapter 1, there are 224 questions. If you can do all those 224 questions clearly, that is more than enough. Okay. So do the workbook questions. Very good. 150 plus question done. Very good. In 2-3 questions you got some difficulty. Very good. So I will do otherwise I'll do one thing. So I have not downloaded the workbook. So one day we will do the workbook questions. Whatever the questions you have doubt, on the spot I will explain. Okay. So do you feel that my class is helping you, whoever is following? So do you feel that while doing the workbook questions, do you feel that they are easy? Or no sir, your class is okay, but while doing the workbook, we are unable to do the questions. We are able to do the questions in the class, but it is not helping in doing the workbook. So anyone is feeling like that? Are you able to do all the questions from the workbook? Maximum? At least. So at least 80%. See guys, I can do one way. So concept I do and workbook questions. So okay, this is the workbook question. Do ऐसा नहीं है. So मैं ऐसा नहीं कर रहा हूँ. So what I'm doing here? So I am giving the concept. I am giving my own style of questions. Then based on that, this is the measurement. I already told you. If you can do the workbook questions and if you can do the previous questions, that indicates okay, you are receiving the subject in a nice way, means I am reaching you. Okay, because why I am not doing the workbook in the class, because the thing is with this concept, if you can do the workbook, that is you can improve your own way. So you will get the ideas. Okay, this is the question. Okay, so this is the way. If you try, that makes you stronger. Okay, and if I do every question in the workbook, then where will you get the practice? Already we are doing these questions in the classroom. So if I do the workbook, then there is no meaning. When will you do the practice? When will you get improved? When will you get develop? So if you do the practice, the workbook and previous questions, it makes you stronger and practice. Okay. Video solutions I will be upload. Don't worry. Answer key I will send. I didn't send. I forgot it. Now only in the break I send. Sir, the question in the workbook, we are getting them directly. I am understanding the language clearly as you have taught in an expert way. Overall, मजा आ गया सर. सर लग है नहीं रहा का कि लग है नहीं रहा कि पेपर में भी ऐसा ही आता है. No doubt you will get the questions. You can do questions from the paper also. Good. Good. Yeah. I am in the starting of workbook only. Sir, please share the workbook solutions separately. Workbook solutions I don't share. Okay. I'll give you the key. And video solutions I will do because I don't have the time to do the video solutions. So, okay, once I get free time, definitely I'll do. Okay. So, maximum in 1 week, already I have completed the TOC in offline. In another 1 week, CD will be completed for offline. And once I complete the CD, I will become completely free. Except your class, I don't have any other class. So, morning time completely I will do. So, if I do in 1 or 2 days, I will complete that video solutions. I can upload. Okay. Why very few people are responding? Why others are not responding? Are you not getting? There may be so many students, na? Why others are not responding? What about Ritu? Are you there? Are you doing the workbook? Have you started the workbook? If you are not getting, so please watch the recorded video once again. Otherwise, if any doubt, because as you don't have the time, I may not give the, I may skip your messages. If you have any sent any message, just directly call me. So as we are running, so you must be clear in every concept. Call me. I will be free after morning and the daytime I won't be free. It is very difficult to reach me. So after 10 o'clock you can call me in the night. Otherwise in the daytime you can call me between 1 o'clock and 2 o'clock, that range. In lunchtime I have 1 hour time. So that time also I may not be free because students will ask some doubts. Okay, anyway, if you want to reach me directly, you can call me in this. So you can make a WhatsApp call. Don't call directly because my number won't be reachable. Okay. Okay guys, we'll continue. Okay, these are the concepts and properties we have done. So now we will see where the regular languages are not closed. Till now we have not, we have seen where the languages are closed. Regular languages are closed. Regular languages are closed under all these properties: union, intersection, concatenation, cleans closure, positive closure, left quotient, right quotient, exclusive or exclusion, or NAND, NOR, homomorphism, inverse homomorphism, substitution, and then minimum, maximum, prefix, suffix, and alternative and cycle of all these closed. Okay, Now we will go for where it is not closed. Chalo. Regular languages are not closed under subset, superset, infinite union, infinite intersection, infinite subtraction or infinite set difference. Okay, so set difference also there. I have set difference closed, but infinite set difference is not closed. Okay, now guys, actually in these operations no language is closed. No languages are closed. No languages are closed. Under these operations, no languages are closed under these operations. Okay, subset, superset, infinite union, infinite intersection, infinite set difference. No language means regular languages are not closed, CFL are not closed, context free, context sensitive languages are not closed, recursive languages are not closed, recursively enable languages are not closed. So what are these CFL, CSL, recursive enable? We will see in future. Okay. After TOC CD and all CD, after TOC CD and OS also pending expired date of full syllabus complete, sir. I cannot give you bus. I am the faculty. I am not the scheduler. Okay. See, most probably, okay. This is November 1st today. So I think I am expecting I will complete TOC and CD by November 20, both I am expecting, because once after next week, means maybe after 3-4 days you may have a little bit lengthy classes. Otherwise, definitely after 10 days you will have lengthy classes, because every day like this, if I take the 3.5 hours, December तक चलेगा both TOC and CDG complete करने के लिए. Okay, because we are going very slowly, one thing. Okay, if I go fast, this is the tough subject. I can go CD faster, but some of you cannot understand, and this subject again if I go fast. So anyway, I am expecting I will complete both the TOC and CD by 20th of this month. Okay, TOC will go up to another minimum. Okay, so at least November 12th 13th तक चलेगा this month. Okay, and slowly I'll go see, depends. If I take only 3.5 hours like this, so it will go up to November ending. Don't worry, after 1 week or some days, this said after the digital all thing it will be finished now. So maybe in Monday or if not Wednesday onwards, I will take more number of hours. Then we can finish early. Chalo, subset. Okay, what is the meaning of this one? Look at this. Subset. If L is regular, its subset may not be regular, not closed under, means it don't say it never regular. Okay na? Not closed means sometimes it may be regular, sometimes may not be regular. If you say closed means always regular. If you take a language L, its complement is always regular. If you take a language L, regular language, its complement is always regular. Clean scrolls are always regular. Reverse is always regular. Okay, if you take two languages, always union regular, intersection regular, subtraction regular. But if you take a one language, its subset may be regular, may not be regular. If always subset, every subset of regular is also regular, then only we will say closed under subset. But sometimes it is not closed. Okay, example. L equal to a power m, b power n, m comma n greater than 0. What is the language, guys, here? Any number of one or more A's followed by one or more B's. One or more A's followed by one or more B's. Okay. So no relation. Powers are different. No relation. Here also no relation. So this is regular. Are you following? This is regular because no relation, no comparison, always regular. No comparison is always regular. Okay, is regular. Now guys, what kind of strings this language will have? One or more A's followed by one or more B's. One or more A's followed by one or more B's means A's are suppose 10. B's can be more than 10 or less than 10 or equal to 10. Suppose A's are 50, B's can be more or B's can be less or B's can be 50. So suppose A's are 100, A's are 100, B's can be more, B's can be less, B's can be equal. So this language will have unequal number of A's and B's as well as equal number of A's and B's. So I am taking all the strings where equal number of A's and B's. A, B will be there. In this language, A square, B square will be there. In this language, A cube, B will be there. In this language, A power 4, B power 4 will be there. A power 5, B power 5 will be there. A power 6, B power 6, A power 7, B power 7, so on. Infinite strings will be there. Those are having A's and B's equal. A power 100, B power 100, A power 200, B power 200, A power 1000, B power 1000, A power 1 lakh, B power 1 lakh. Oh, so many infinite number of strings will be there. This is the language which is having any number of A's followed by any number of B's. This one given language. So in that unequal A's and B's will be there, equal A's and B's will be there. So I am taking equal and A's and B's. So what is the general repetition? This is A power I, B power I greater than 0. Okay guys, now tell me Is this regular, not regular? Comparison, relation is there. What is the relation? A and B is equal, and relation is infinite. Is not regular. Is not regular. But guys, have you observed? L dash is subset of L. L dash is subset of L. Okay. So L dash is subset L. L is regular. L is regular. Its superset is regular. Its superset is regular. But subset L dash is not regular. So this is the meaning of regular language are not closed under subset. Okay. Copy. Okay. Counter example, how to find? You need not to find anything counter example, boss. Okay, just learn these concepts. Okay, they don't ask you what is the counter example. Okay, even though so everything will be given options. This is, you are not writing any descriptive. It is completely objective or numerical. This is the last slide only. Subi Goyal, you must be fast. Every time you are asking, okay, you please make your copies, do fast, increase your speed of copying. Okay, next. So this is copied. We will go for next one. This is about subset, guys. Okay, superset is also not closed. Superset. I am going for superset. Okay, shall I go? Okay, now next one, closed under, if L is regular, its subset may not be regular. Its superset is also not regular. Superset also may be regular, may not be regular. Like, look at this. If L is regular, implies then its superset may not be regular. Okay, see the example. Let L equal to A power n, B power n less than or equal to 100. Guys, tell me, is this regular or not regular? Guys, is this regular or not regular? Relation is there, na? When relation is there, not regular, na? Hello? Are you following? When relation is there, not regular, na? What? Guys, relation is there, comparison is there, but that comparison is finite, na? So relation finite, comparison finite is regular. Are you following? Relation is there, but that relation is finite, so this is regular. Are you following? Relation finite, regular. Now guys, I am taking L dash, A power n, B power n greater than or equal to 0. Guys, now tell me, here relation A power n, B power n and infinite is not regular. Are you following? This is relation infinite, not regular. Whereas here relation is finite, regular. Okay. Now guys, listen. Here L is subset to L dash. So L is subset, L dash superset. L is regular, and its superset, L dash superset is not regular. Okay, not regular. Do you understand? So if a language is regular, its superset need not be regular. If a language is regular, its superset need not be regular. May be regular, may not be regular. So take this one. Okay. Okay, next. Guys, next one is infinite union, infinite intersection, infinite set difference. Okay, infinite union, infinite set difference means if L1 L2, L3, L4, so on. Regular, okay? I'll give the example better. Next, let L1 equal to a power n, b power n, n less than or equal to 3. L2 equal to a power n, b power n, n less than or equal to 5. L3 equal to a power n, b power n, n less than or equal to 7. Next, so on. L50 equal to a power n, b power n, n less than or equal to 101. Now guys, look at this. Hello, here relation but finite, it is regular. Relation finite, regular. And here also comparison finite, regular. Comparison finite, regular. This also regular. Okay na? Now look at this guys. L1 union L2. What will you get? L1 union L2. A power n, b power n, a power n, b power n. So what is L1? Epsilon ab, a square b square, a cube b cube. What is L2? Epsilon ab, a square b square, a cube b cube, a power 4 b power 4, a power b power 5. So L1 union L2, what will you get? You will get a epsilon to a power 5 b power 5. So n less than or equal to 5. It is regular. Yes or no? Now if I take L1 union L2 union L3, a power 5, a power n, b power n, n less than or equal to 7. So on union L50, this union, what will you get? You will get n less than or equal to 101, 101. Okay. Now guys, tell me, is this regular or not regular? Of course, relation and it is finite. This is regular. Okay guys. Now look at this. How many languages I have taken the union part? 50 languages. L1 union, L2 union, L3 union, so on L50. Means finite languages I have taken or infinite languages? Finite languages. Therefore you can say regular languages are closed under finite union. Finite union means, what is the meaning of finite union? If you take the union of some countable languages, in which every language is regular, L1 regular, L2 regular, L3 regular, L4 so on. You take 100 languages, their union is regular. If you take 1000 languages, their union will be regular. So union of finite number of regular languages is regular. So that is regular languages closed under finite union. Okay guys, now look at this one. Now look at this. Okay, are you following? Now tell me, suppose L50, then L51, then L52, then L53. Okay, L51, L52, L53, so on, infinite. Then what will be this language guys? Then what is L51? A power n, b power n, n less than equal to 103, then 105, then 107, then 1007, then so on, infinite. Then one or infinite. So I am taking the union of infinite languages, whereas every language is regular. Infinite language I am taking. Then what will be the result here? So what will be the result? A power n, b power n, n less than or equal to infinite. Meaningless, boss. N less than or equal to infinite. What is that? Is there any meaningful statement? Meaningful statement this one? So there is no meaning to the n less than or equal to infinite. So here a power n, b power n. So what we can say? n greater than or equal to 0. Are you following? Are you following? So L1 is regular, L2 regular, L3 regular, so on every language regular. If I take so on infinite, then A power n, B power n greater than or equal to 0. Hello guys, what about this one? Relation infinite is not regular. This is not regular. Okay, whereas whereas every language is regular, but their infinite union is not regular. So this is regular languages are not closed under infinite union, whereas closed under finite union. Regular languages are closed under finite union, but not closed under infinite union. Okay, you can copy this, guys. Okay. Okay. Next. Copied. Next. So copy this also, regular language closed under finite union. Then one more thing, every finite language is regular. Every finite language is regular. Okay, what is the meaning of finite language? Already while deciding the regular or not, that time I have told you every finite language is regular. The finite language means the language having countable number of strings, finite number of strings. The language having finite number of strings is finite language. The language having finite number of strings is finite language. Okay, countable number of strings. Every finite language is regular. Now, so guys, this is done. What is the next property? Infinite. So infinite union. Okay. Subset done, superset done, infinite union done. Now infinite intersection. then set difference. L1 minus L2 minus L4 minus L5 minus so on, okay, minus infinite. What is this? Okay, now guys, just look at this, just hold on. What is L1 minus L2, guys? L1 minus L2 is L1, okay, no, one second. I'll go for intersection. First is intersection, I'll go for intersection. L1 intersection, L2 intersection, L3 intersection, L4 intersection, L5 intersection, so on. Okay. Now, we have there is one formula, L1 intersection L2. What is L1 intersection L2? L1 bar union L2 bar whole bar. Okay. Means it is what? De Morgan's law. Is De Morgan's law. What is De Morgan's law? De Morgan's law. Okay, this L1 union L2, that is A intersection B equal to A bar union A complement union B complement whole bar, or A bar union B bar whole bar, or A union B equal to A bar intersection B bar whole bar. These two are the De Morgan's laws. Okay. Okay, now copy it. Now look at this, guys. Hello guys, I do one thing. L1 intersection L2 intersection L3 intersection so on. Can we write like this? L1 bar using this formula can we write it as L1 bar union L2 bar union L3 bar union L4 bar union L5 bar union infinite whole bar. Okay na? Now guys, look at this. L1 is regular. What is this? If every language is regular, L1 regular, L2 regular, L3 regular, so on, infinite languages are there. All of them are regular. Then what about their intersection of all these? Okay, L1 is regular complement union. L2 is regular complement union. L3 is regular, its complement union. L4 regular, its complement union, so on, infinite. Now what is its complement? Okay, now look at this, guys. Regular complement is regular. Every complement of a regular language. Okay, every complement of regular language means if L is regular, its complement is also regular. Union, regular bar is also regular. Regular complement, regular complement, regular complement, regular, infinite. Okay, now guys, it's all complement. Okay, guys, regular union. What is this? Infinite union. Regular languages are not closed under infinite union. Hello guys. It is regular, union, regular, all. So union of all infinite regular languages, union of infinite regular languages, all are infinite union of regular language otherwise. Okay, this is infinite union of regular language, not regular, and its complement. If a language is not regular, its complement is also not regular. Say, okay, if you have any doubt, just keep it. We will see in converse of property. I will clear it, this one. Okay, so guys here, intersection of infinite languages is not regular. Intersection of infinite regular languages is not regular. Copy this. Okay, next one, infinite subtraction. That is set difference, L1 minus L2, L1 minus L2 minus L3 minus L4 minus L5, so on, infinite. Okay, guys, you know na what is L1 minus L2? L1 minus L2 is L1 intersection L2 bar. L1 minus L2 is L1 intersection L2 bar. So we can write this as L1 minus L2. This part we can write it as L1 intersection L2 bar. Okay, this part L1 intersection L2 bar. Okay, now this minus L3. So this minus L3, how can we write? This intersection L3 bar. Okay, so this. Now this minus L4, so intersection L4 bar. Okay, next minus, okay, this intersection L5 bar, so on, infinite. Hello guys, are you following here? So L1 regular intersection here, L1 regular intersection, regular complement intersection, regular complement intersection, regular complement intersection, regular complement intersection, 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 infinite. Okay guys, regular intersection, regular intersection, regular intersection, regular intersection, 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 infinite. And regular languages are not closed under infinite intersection. Just before this we have seen, because regular, 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 intersection, infinite, not regular. Okay, so set difference is not closed. Okay, next, this is about okay. Next, converse of properties. Converse of properties. Converse of properties. This is also important. So please, converse of properties. Converse of properties. Okay, so this is also important. Just look at this. If L1 union L2 is regular, if L1 union L2 is regular, what guys, if L1 and L2 are regular, so actually what is the what we have learned, if L1 and L2 regular, then L1 union L2 is also regular. Okay, so this is the property we have seen. If two languages are regular, their union is also regular. So what is converse? If L1 union L2 regular, then what about this one? You know what is converse and inverse? So suppose a statement is given, P implies Q. This is the statement. What is the converse? Converse means Q implies P. This is converse. Now, what is inverse? Negation P, negation Q. This is inverse. Okay. This is inverse. And what is contrapositive? Negation Q and negation P. This is contrapositive. Okay. Okay. So if a statement is given P implies Q, Q implies P is the converse, negation P, negation Q is the inverse, negation Q, negation P. Contrapositive always true. Contrapositive always true. If a statement is given, its contrapositive is always true. Always true. Converse in and inverse may be true, may be false. Okay, depends. We will see in last topic, countability, uncountability. There I will tell you this one. Okay, again means not means using this I'll tell you one or two statements. Okay. So this is what is converse here. So, suppose if L1 L2 are regular, 100% L1 union L2 is also regular. Now what we are doing now, suppose two languages are their union. If the union of two languages is regular, what about L1 and L2? That is the question now here. Okay. So I am deleting this. So if L1 and L2 are regular, then L1 and L2 need not be regular. If L1 and L2 are regular, then L1 and L2 need not be regular. I'll give you the proof. Okay. Let L1 equal to A power n B power n greater than or equal to 0, or you can say greater than 0. Okay guys, is this regular or not regular? Hello, is this regular or not regular? This is not regular. Why? There is a relation and it is infinite. Relation and infinite. Are you following? Hello guys, following? Okay, this is not regular. I am taking the another language L2 equal to A plus B whole star. So what is A plus B whole star? It is regular. Because we can consider a finite automata. What is the finite automata for A plus B whole star? This is the finite automata, A plus B whole star. Okay, A plus B whole star. This is. Now guys, if L2 is regular, L1 is not regular. Okay. Now what is L1 union L2? L1 union L2 equal to L1 is A power n B power n union A plus B whole star. What is A plus B whole star, guys? A plus B whole star is everything, na? All combination of A's and B's. So A power n B power n also A plus B whole star. So A power n B power n, every string is also in A plus B whole star. So this union A plus B whole star, what will you get? You will get A plus B whole star. A plus B whole star. So this is regular. A plus B whole star is regular. But see, here union is regular, but individually one is regular, the other one is not regular. One is regular, other one is not regular. Okay? Of course, both can be regular. If both are regular, 100% union is regular. But you see here, even though one is not regular, I repeat, if L1 union L2 is regular, both can be regular, or one can be regular. Example here, one is regular, the other one is not regular. Even though L1 is not regular, L1 union L2 is regular. Okay, na? So copy this. I'll give you one more example. Okay, now guys, we'll see one more example. Okay, now copied? Copied? Now guys, look at this one. I'm taking L2 a different language. L2 a different language. Anyway, L1 is regular. L1 is regular. What is its complement? What is its complement? Okay. Its complement. What is the complement language? Sigma star minus A power n B power n. Sigma star minus A power n B power n. Okay. So guys, L1 is L1 is not regular because comparison is there, comparison and it is infinite, not regular. And L2, its complement is what? Its complement will have every combination of A and B. I repeat, L2 will have every combination of A and B except those strings are in the form of A power n, B power n. So whenever I give a string like this, should I accept this string? No, don't accept because invalid. And don't accept. Should I accept this string? Don't accept because this is also invalid. So like this, how many strings will be there? Infinite. So you should not accept all these. Accept these, you can accept remaining. So whenever a string is given, I have to check whether A's and B's are equal or not. So if equal, don't accept, otherwise accept. So here comparison in relation infinite. So this is also not regular. This is not regular. Is not regular. Is not regular. Okay na? Now guys, look at this one. What is L1 union L2? What is L1 union L2? L1 union L2 is A power n B power n is L1 union okay, L1 is this one union L2 sigma star minus A power n B power n. Are you following? So L1 is this one, L2 is this one. So here, can you cancel this one? A power n, B power n. Then what will be left? Sigma star. What is sigma star? Sigma star is nothing but A plus B whole star. What is A plus B whole star? Is regular. Is regular. Why? Why? Because we can consider a finite automata which is any combination of A and B. Any combination of A and B. A plus B whole star. That's it. See guys, here L1 is not regular, L2 is also not regular, but their union is regular. Are you following? In the previous example, L1 union L2 is regular. Out of L1 and L2, L1 is not regular, but L2 is regular. In the previous example, L1 is not regular, L2 regular. Okay, now here both of them not regular. Both of them not regular, but their union is not union is regular. Therefore, if L1 union L2 is regular, if L1 union L2 is regular, both L1 L2 can be regular. One case, both L1 L2 can be regular, or one of them can be regular, or none of them can be regular. Are you following? L1 union L2 regular means both of them can be regular, one of them can be regular, or none of them can be regular. All these three options can be possible. Example, a theoretical question may come like this: which of the following statements is true? Okay, if L1 union L2 is regular, if L1 union L2 is regular, then which of the following statements is true? Option A, both L1 L2 are regular. Option B, one of them is regular and the other one is not regular. Option C, both of them not regular. Are you following? Option A, both of them regular. Option B, one of them is regular and the other one is not regular. And C, both of them not regular. Option D, all. All is the right answer. Are you following? Okay. Madhav, you are very fast. For your question, the answer is this one. Okay? Okay. You understand your doubt? The answer is this one. Okay, Abhijit. Yes, comparison infinite not regular. This is also not regular. Chale, we'll go for next one. So this is converse of properties. This is one. Okay. Next we will go for. Okay, copied. Next one. Next one, guys. Suppose L1 intersection L2 is regular. L1 intersection L2 is regular. Then L1 and L2 need not be regular. L1 and L2 need not be regular. Okay, if L1 intersection L2 regular, then L1 and L2 need not be regular. Okay. Now we see the proof. Guys, listen. Look at this one. Hello, L1 is A power n, B power n greater than equal to 0, not regular, not regular. L2 sigma star, this also not regular. Then what is the intersection of these two? What is the intersection of these two? What is the intersection of these two? Whatever in L1 and L2 is complement of L1. L2 is complement of L1. Whatever in L1, not in L2. Whatever in L2, not in L1. Okay? Whatever in L1, not in L2. Whatever in L2, not in L1. So there is no common string at all. So L1 intersection L2 equal to 5. What is 5? 5 is a regular, boss. Regular. How regular? We can consider a finite automata. Empty. A wala empty. No final state means L is empty. L is empty. So it is regular. Are you following? L1 is A power n B power n. L2 is L1 complement sigma star minus A power n B power n. Whatever in L1 will not be in L2. Whatever in L2 will not be L1. Will not be in L1. So there is no question of any common string. Means L1 and L2 is empty. Empty. Therefore, and empty is a regular. So intersection is regular. Intersection is regular. But individually L1, L2 is not regular. Okay. Individually L1, L2 is not regular. Otherwise, I'll give you a better example. Okay. Don't worry guys. I will give you a better example. Okay. If you are feeling any uncomfort in this example. Okay. Now go for this guys. Okay. Guys, look at this one. Here, A power n, B power n, not regular, you know very well, because relation, comparison, infinite. Here also, A's are any number, B's must be multiple, double. A's followed by B's are double, A's are 2, B's are 4, A's are 10, B's are 20, A's are 100, B's must be 200. Comparison, infinite. Relation, infinite, not regular. Relation, infinite, not regular. Guys, what is the intersection of these two? Here A's and B's are equal. Here A's and B's, okay, A's followed by B's multiple. B's are double. B's are double. I say double. But B's are double to A's. Here A's and B's are equal. Here B's are double to A's. So what is the intersection? Here intersection except epsilon. Except epsilon, no one is here. When n is 0, A power 0, B power 0, epsilon. Here also when n is 0, A power 0, B power 2 into 0. A power 0, B power 2 into 0, B power 0. A power 0, B power 0, epsilon. Only epsilon is the common strings. No other string is common in L1, L2 and epsilon. What is epsilon automata? This is the automata. Epsilon automata is this one. So this is regular, Okay, L1 intersection L2 is regular. But individually L1, L2 are not regular. हो गया, समझ गया? Copy. Oh. Okay, next one. Okay guys, so both are not regular. Okay, one can be regular. Example, I'll give you one more example. Okay, I'll give you n less than equal to 10. Okay guys, here relation is if relation finite is regular. Are you following? Here relation finite, regular, and A power n, B power n greater than equal to 0 is not regular. Relation infinite. So what is the intersection here? Intersection here epsilon AB, A square, B square, A cube, so are infinite. Here epsilon AB, A square, B square up to A power 10, B power 10. What is the intersection here? A power n, B power n less than or equal to 10. So this is regular because relation infinite. Are you following? In the previous case, intersection was regular, but individually L1 is not regular, L2 is not regular. Okay, both of them not regular. Here, intersection is regular, and one is not regular, other one is regular. So, when intersection L1 intersection L2 regular, three possibilities. Both of them can be regular, one of them can be regular, none of them can be regular. Are you following? If L1, L2 regular, intersection is always regular because properties we have seen. Or none of them can be regular, previous example. Or only one is regular, the other one is not regular, present example. Okay, yeah. Okay. Okay. Okay, guys. Madhusudan, sir, you teach so simple and nicely. Perfect teacher. Everybody is perfect in made easy. Remember that. Okay, guys, we'll go for break. Thank you. So,